Well, hi everyone, this is Chiranjeevi, and in today's video, we are going to talk about the template design pattern. So, this template design pattern is a pretty straightforward and a simple design pattern. And what it tries to say is it lets you define the skeleton of an algorithm and allows subclasses to redefine certain steps of the algorithm without changing its structure. So, you might be thinking, why will you need a template method pattern? So you can imagine it like this. So I'm showing you this image like this is a piece of puzzle which connects to each other in a certain way. And what template design pattern tries to tell you is how can you connect these pieces together. So all these connection points and the way you can connect each piece together is the essence of this template design pattern. And now what you are free to do is you're free to choose the picture you want to paint on these pieces. Okay, so you can choose that this piece can be of red color and this piece can be of blue color and the remaining can be of yellows. So this power is given to you to decide what color of the pieces you want to build, but how the pieces will connect internally will always be fixed, and that will be provided by your template. So we see that we have a template here, and using this template we can actually change the color of these pieces and create some cool little diagrams. So that's what you can try to imagine template design pattern, what it tries to do. And now I'm going to show you using a small example how we can implement this. So first let's take a look at this UML diagram for template design pattern, which is also a straightforward and very simple UML diagram. So we have abstract class for this template design pattern, which has all these steps. Now, by steps, I mean the steps for the algorithm you're trying to abstract. So your algorithm can be anything. Your algorithm can be a sorting algorithm. Your algorithm can be brushing your teeth. Your algorithm can be like formatting a USB drive. So any algorithm you want to abstract, you have to put its abstracted steps in the abstract class for this template. And in this template method, what you will do is you will call these steps in order for the algorithm you want to execute. Producer of this abstract class or this template class defines in which order this algorithm executes. So you will define all these steps, like if step 1, call step 1, if step 2 is true, then call step 3, else call step 4. Now it depends, like you can provide a default implementation for these steps to provide a default way of executing the algorithm, but on the other hand you also provide the consumers of this template to define their own steps so they can modify the algorithm at certain touch points to get their own flavor of what they are trying to do. So in order to implement this, I have created 4 small steps which we will go through one by one and create this template method pattern in action. So the first step says create an abstract class which contains the algorithm to do something. Capture algorithm steps in different methods and the actual algorithm in a default method. So for this example, what I'm going to do is I'm going to create a very simple algorithm for making pizzas. So let's go ahead and define a default method. So let's define a method called make here. Now, while making pizzas, we can have certain steps. So what we will do here is we will abstract all these steps into methods. So let's create a method for choosing the bread. So we can say public abstract void, since we want the implementation of this method to be abstract so that it could be provided by the classes which extend this abstract class. So let's say public abstract void select bread. Now similarly we can provide multiple steps for the method we want to abstract out. So the first step for select bread, we can also have a step for choosing ingredients. We can also have a step for baking at some temperature, and pizza is incomplete without any toppings, right? So let's add a step to actually include toppings. And last but not the least, let's also have some cheese. Okay, so in the make method, what we will do is we will define the order of the steps in which this will be called. So let's select a bread before making a pizza. Then let's choose some ingredients. After choosing ingredients, let's add toppings, and at the top let's add cheese, and let's bake at some temperature. So this is the algorithm part. So this is the default method what I mentioned in the first step, which contains your actual algorithm and the way you want to execute it. Now, since this algorithm right now does not do anything because all these steps are not having any implementations at all. So now what we will do is we will go ahead and create a subclass for this pizza maker and extend that. So in the second step, I am making those steps abstract, and you want your consumer to provide their own implementation. So we have done this step also. Now let's go to the third step. The third step is to extend this class containing the algorithm and provide implementation for these abstract methods. So let's go ahead, and I have already extended this class. So let me go ahead and implement the methods for this class. So now I have implemented the methods for this class. Let me add a very small implementation for all these methods, just in order to show you how this template pattern works. So let me say selecting bread dot dot dot. So let me copy this print line statement in all these methods so that it's quickly I can show you how this works. Adding cheese, adding toppings, baking, add temp, selecting ingredients. So now we have created this simple cheese corn pizza maker, which extends our abstract pizza maker with all these steps defined. So now what we want to do is we want to use the default method to execute the algorithm for the job. So let's go to our main method and create a pizza maker. So pizza maker cheese corn maker is equal to new simple cheese corn pizza maker. Now what we need to do here is just call the make method, and this will actually delegate the call from this make method to this implemented methods which we provided in the simple cheese corn pizza maker. So if you go inside this make method, it only calls the select bread, choose ingredients, add toppings, add cheese, but all these methods are abstract. But what we are trying to do here is we are using a parent reference to hold a child class. So what this will do, this make will delegate calls to this child class which has provided all the implementation for this method. So why template method is handy is, first let's run this program and see that we are getting our pizza. Okay, so this is happening. Now what we can do is we can discuss about why template pattern. So the reason behind why template pattern is you have a set of steps which you want to be executed in a predefined order, but you don't want to tightly couple the steps with the execution order. You want that steps can be changed or steps can be provided in different flavors at runtime. So what you do is you create a template for this algorithm and you define your steps and you make your steps abstract. Now what you do is you provide your own implementation for your algorithm and define those steps, concrete steps, so that you can actually tweak and control your algorithm behavior on each and every point, which makes it a little handy. So if you observe closely, strategy and factory can be considered as a part of template design pattern. So here we are using so many strategies to actually inject these steps. So this is how template design pattern helps us to model an algorithm and provide a template for it, and then provide a subclass which can go ahead and implement those abstract steps. Alright, so this is what template design pattern is trying to do. It lets you define the skeleton of an algorithm and allow subclasses to redefine certain steps of the algorithm without changing its structure. And that's what we saw in the example. So that's all with this template method pattern. I'll see you in the next one. Thank you.